Now we are starting a new topic, new chapter, binomial theorem. Say students, you know how to expand a plus b whole square, a minus b whole square, a plus b whole cube. You can also expand a plus b whole raised to 4. If these indices are smaller positive integers, then we can expand this. Because you know formula for a plus b whole square, a plus b whole cube, a minus b whole square. But if you want to expand a plus b raised to 15, this power is higher, then its expansion becomes difficult. So how to expand such expressions, that we will discuss in this topic. So if this index, if I say it is n, if n is higher, if n is any positive integer, then to expand it, the formula is a plus b raised to n is equal to nc0 into a raised to n plus nc1 into a raised to n minus 1 into b raised to 1 plus nc2 a raised to n minus 2 b square plus, in general, see which pattern we are getting here. If see everywhere this is n, nc1, nc2, so I keep here n. Then say here 0, 1, 2. So suppose r is variable, ncr, e raised to, see same number is here 2, 2, 2, 1, 1, 1. So I keep r, n minus r, b raised to r. See if you take r0, then we get first term. If you take here r1, 1, 1, so first term. If you take r2, 2, 2, 2, this is next term. So this is a general pattern for terms in this sequence. And here last term is ncn b raised to n. So expansion for a plus b raised to n is nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b square, so on up to ncn b raised to n. So this is a general term in this expansion. This expression, in short, it can be written as, in short, this can be written as a plus b raised to n is equal to sigma nck. See here k is a variable, nck a raised to n minus k b raised to k, k is 0 to n. Or you can use here variable r, ncr, n minus r, b raised to r, and r is from 0 to n. So it does addition. NC 0, a raised to n, b raised to 0. Then NC 1, a raised to n minus 1, b raised to 1. So last value of r is NC n, b raised to n. So this is short form of this expansion. Then now in this formula, if I replace b, I am replacing b by minus b. So replacing b by minus b, a minus b raised to n. So here this is result 1, this is result 2. A minus b raised to n is equal to, everywhere I am replacing b by minus b. So say here I will put minus b, here I will keep minus b, here I will keep minus b. Everywhere wherever b is given, I will keep minus b. Here it will be minus b. So in this formula, I am replacing plus b by minus b. So it will be converted into this form, NC0 a raised to n plus NC1 a raised to n minus 1 into minus b raised to 1. Minus b raised to 1 is minus b. So in multiplication, this minus comes as main sign. So keep minus b, then plus NC2 a raised to n minus 2 b square. Now here I am replacing this b by minus b. So minus b square is b square. So it remains unchanged, b square. So this will be plus, because replacing b by minus b square is plus b square, so it remains plus. Then next we'll have b cube. Next term contains b cube. So in b cube, if you replace b by minus b, then minus b whole cube, it is minus b cube. So next term will have minus sign, minus NC3 a raised to n minus 3 b cube. In general, here see what we are doing. In general term will be NCR a raised to n minus r, and here b we replace by minus b. B is replaced by minus b. So this sign depends on this power r. If this is even, this will be positive. If r is odd, this will be negative. That is plus, and last term will be NCN minus b raised to n. So last term also depends on this power n. N is positive, n is even, this will be positive. If n is odd, main sign will be negative. So here this is expansion. It can be taken as expansion for a minus b whole raised to n. So from first line you can remember second line. In short, expanding a minus b whole raised to n, we keep alternate sign, plus minus, plus minus, plus minus, plus minus. Automatically it ends at either plus or minus. So this is expansion for a minus b raised to n. Now see, now in first formula I replace a by 1 and b by x. Replacing a by 1, b by x. So everywhere I replace a by 1. 1 raised to n is 1, 1 raised to n minus 1 is 1, 1 raised to n minus 2 is 1. So wherever a is given 1 raised to anything, it will be 1. So it is equal to here nc0 1 raised to n is 1 plus nc1 1 raised to n minus 1 is 1 and b is replaced by x. So it is x plus nc2 1 raised to n minus 2 is 1 into x square plus nc3 x cube plus in general ncr x raised to r and last ncn x raised to n. And here short form of this, it can be written as 1 plus x raised to n is sigma ncr x raised to r. R is 0 to n. So this is short form of this expression in sigma form. It can be written by this way. Then as we have written the second statement, similarly this statement can be converted into replacing x by minus x, alternate sign, nc0 minus nc1x plus nc2x square minus nc3x cube plus here ncr, here x is replaced by minus x, so minus x raised to r plus ncn minus x raised to n. So here main sign plus or minus depends on power. N is even, there will be here plus sign. If n is odd, its sign will be negative. Similarly here, if r is even, here sign of this term will be positive. If r is odd, sign will be negative. So these are main 4 statements on which we will work. Now observe here, in the expansion of a plus b raised to n, in expansion of a plus b raised to n, in the expansion of a plus b raised to n, formula for general term, formula for general term is, say this is formula for general term. What is order of that term? Say look here, this is first term, this is second term. When I am speaking second term, here 1 is written, this is third term. Whatever is here written, I am speaking one more. Say first term, second term, third term. So this will be r plus 1th term. So r plus 1th term is general term. That is r plus 1th term. R plus 1th term. Formula for r plus 1th term is denoted by tr plus 1. It is ncr e raised to n minus r b raised to r. This is formula for r plus 1th term. Similarly, in expansion of a minus b raised to n, r plus 1th term is equal to, this is r plus 1th term in a minus b raised to n. So it is ncr a raised to n minus r. Only you have to do, what you have to do, one change, replace b by minus b. So minus b raised to r. So it is r plus 1th term in expansion of a minus b raised to n. Then r plus 1th term in 1 plus x raised to n. So this is r plus 1th term in 1 plus x raised to n. And in expansion of 1 plus x raised to n, r plus 1th term is equal to NCR x raised to r. In 1 plus x raised to n, that is r plus 1th term. Similarly, in 1 minus x raised to n, this is r plus 1th term. And in 1 minus x raised to n, r plus 1th term is NCR minus x raised to r. So from these 4 statements, these 4 formulas for a general term can be remembered. Now look here. Count number of terms in the expansion of a plus b raised to n. Say here, this is first term, this is second term, this is third term. So this will be n plus 1th term. So remember, number of terms in the expansion of a plus b raised to n. Number of terms in the expansion of a plus b raised to n is n plus 1. So if n is odd, then number of terms will be even, one more. If n is even, this will be odd. As for example, if we expand x plus y raised to 11, suppose I take here 10. So n is 10. So number of terms in the expansion of x plus y raised to 10 is 11. So that is 11. So first, second, third, 4, 5, 6, 7, 8, 9, 10, 11 terms. Expansion has 11 terms. Now look, order of a middle term. Because these are 11 terms, see, if you leave 5 from left side, 5 from right side, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 if you leave from left side, 5 from right side, this is middle term. This is middle term. What is order of this middle term? It is 6th term. This is 6th term is middle term. That means 10 by 2 plus 1. 10 by 2 plus 1. 5 plus 1. So if this number is n, then order of a middle term is n by 2 plus 1. So therefore, in a plus b raised to n, if n is odd, say in this whole discussion, n is natural number. In every formula we are going to take n a natural number. So if a plus b raised to n, if n is odd, then middle term is n by 2 plus 1th term is middle term. If this is even, sorry, I did mistake. If n is even, if n is even, if n is even, then n by 2 plus 1th term is middle term. Now if n is odd, suppose here n is 11, power is 11, then expansion has 12 terms. If n is 11, expansion has 12 terms. First term, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12 terms. N is 11, expansion has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. Now find or check order of a middle term. See, these are 12 terms. So if you leave 6 terms from left side, 6 terms from right side, then nothing is left. So to have something in middle, you have to leave 5 terms from left side, 5 terms from right side. These are middle terms. These are middle terms. There are 2 middle terms if n is odd. Now what is your order? So this is 6th term, this is 6th term, and this is 7th term. That means in 11 add 1 and divide by 2, that is 6. Then in this number add 1. So in this number you add 1, that is 7th term. So 11 plus 1 by 2, that is 6th term, and in 6 2 plus 1, so 7. So if n is odd number in a plus b raised to n, if n is odd number, then n plus 1 by 2th term, n plus 1 divide by 2, and n plus 1 by 2 plus 1th term, there are 2 middle terms, are middle terms. So these are important results for this chapter. So whole chapter is based on these results. So learn these formulas properly. Now expand x by 3 plus 1 by x raised to 5. Say it is like a plus b raised to n. We are applying this formula, a plus b raised to n. NC0, a raised to n, NC1, a raised to n minus 1 into b, NC2, a raised to minus 2 into b square, plus up to NCn, b raised to n. So application of first formula. So consider these as a plus, this is plus, then consider this as b, and n is 5, this is 5. So applying this formula, NC0, a raised to n plus NC1, so 5 C1 a raised to, now see power of a is decreasing by 1. So here power was 5, here take power 4, and b is starting, b raised to 1, b raised to 1, plus 5c2 a raised to 5 minus 2, b raised to 2, so 5c2 a raised to 5 minus 2, that is 3, b raised to 2. Say power of a is decreasing, a raised to 5, a raised to 4, a raised to 3. Power of a is decreasing, a is decreasing, and b is increasing, b1, b square, b cube. Then plus 5c3, 5c3 a raised to 3, a raised to, see here it was 3, now 2, and b raised to 3. Then plus 5c4 a raised to n minus 4, 5c4 n minus 4, so 5 minus 4 is 1, b raised to 4, plus 5c5 b raised to 5. So application of this formula, this is a, this is b. A, first term a raised to 5, then a raised to 4, a raised to 3, a raised to 2, a raised to 1, a raised to 0, no a. Here no b in first term, so b raised to 0, then b raised to 1, b square, b cube. So a is decreasing, power of b is increasing. Last term is free from a, first term is free from b. So application of this formula, so it is equal to 5c0 is 5 into, this is x raised to 5 upon 3 raised to 5, 3 into 3 9, 3 into 3 into 3 into 3 into 3, 3 raised to 5, so 9 into 9 81, 81 into 3 243, plus 5c1 is 5, sorry here I have done mistake, 5c0 is 1, 5c0 is 1, 5c1 is 5. Keep remember NC0 is always 1, NC1 is n, NC0 is 1, NC1 is n. So 5C0 is 1, 5C1 is 5 into x raised to 4 upon 3 raised to 4 81 into 1 upon x plus 5C2 5 into 4 upon 2 into 1, so 20 by 2, that is 10. This will be x cube upon 27 into 1 upon x square plus 5c3 is 5c2 and 5c2 is 10. So 5c3 it is also 10 into x square upon 9 into 1 upon x cube plus 5c4 is 5c1, 5c4 is 5c1 and 5c1 is 5 into x by, here sorry this is 3, x by 3 into 1 upon x raised to 4 plus 5c5 is 1, so 1 into 1 upon x raised to 5. So it is equal to, this is x raised to 5 upon 243 plus 5 into x raised to 4 upon x is x cube upon 81 So it is 5 by 81 x cube plus this is 10 by 27 into x cube by x square is x plus 10 by 9 x square upon x cube is 1 upon x, so 9x plus 5 by 3 x cube plus 1 upon x raised to 5. So this is required expansion of this given expression. See here power is 5 and we are getting 6 terms. So application of this formula. Now here 2x minus 3 raised to 6. So application of this formula, a minus b raised to n. Same application but alternate sign. nc0 a raised to n. Then minus nc1 a raised to n minus 1, b is starting. Then plus nc2 a raised to n minus 2 b square. Then minus, then plus, then minus, then plus. So we will continue this up to ncn. So here this is equal to n is 6. So first term is nc0 a raised to n. Consider this as a and this as b. So nc0 a raised to n. First term is free from b. Second term minus nc1, then power of a is decreased and b is starting 3 raised to 1. Then plus 6c2 2x raised to, here it was 5, now 4, and 3 square b square, b is 3. So plus minus plus, now minus 6c3 2x raised to 3 raised to 3. A is decreasing, b is increasing. Power is increasing, decreasing. Then plus 6c4 2x raised to 2 3 raised to 4 plus 6c5, then minus plus minus plus minus 6c5 2x raised to 1 3 raised to 5. Then plus 6c6, this will be last term, 6c6 2x raised to 0 3 raised to 6. So application of this formula for a minus b raised to n. So this is equal to, now 6c0, nc0 is always 1, 2 raised to 6, 64 into x raised to 6 minus 6c1 is 6, 2 raised to 5, 32 into x raised to 5 into 3 plus 6c2, 6 into 5 upon 2 into 1, 15. This is 15 into 16x raised to 4 into 9 minus 6c3, 6 into 5 into 4 upon 3 into 2 into 1, 6c3, it is 20. So this is 20 into 2 cube is 8, so it is 8x cube into 27 plus 64 is equal to 62, and 62 is 15. So 15 into 4x square into 81. 3 raised to 4 is 81. Minus 65 is 61. It is 6 into 2x into 3 raised to 5. 243 plus 66 is 1. This is 3 raised to 6. 3 raised to 6 is 3 into 3, 9 into 9 into 9. So this is 3 raised to 6, 81 into 9, 729. So it is 729. Now calculating this will be 64x raised to 6 minus, this is 32 into 6, 192, 192 into 3, 576, 576 x raised to 5 plus, this is 240 into 9, 240 into 9, 2160. This will be 2160 x raised to 4 minus, this will be 540 into 8, 540 into 8, 4320, 4320 into x cube plus, this is 60 into 81, 4860, 4860 into x square. This is 12 into 243, 243 into 12. So here 243, this will be 486. 2916 minus 2916x plus 729. This calculation can also be done by calci. Using calculator you can do if calculator is allowed. Now using a binomial theorem, evaluate 101 raised to 4 and 96 raised to 3. We want to find a value using a binomial theorem. So if we want to use binomial theorem, then we have to create a plus b raised to n or a minus b raised to n. So look here, number is 101. So 101, we take help of 100 because 100 is the easiest number to calculate power. 100 square, 100 cube, 100 raised to 4, it can be calculated easily without any difficulty. So taking a base 100, now base is 100, so 101 is given, so this can be expressed as 100 plus 1 raised to 4. It can also be taken as 1 plus 100 raised to 4. But from these two, we shall choose this expression, because so we can apply 1 plus x raised to n, that is more convenient form of binomial theorem. 1 plus x raised to n. If you choose this expression, then you have to use a plus b raised to n. In this case you have to take a 100 and b 1. But instead of that ab form, 1 plus x raised to n is more convenient. So this can be expressed as 1 plus 100 raised to n. Now we have formula for 1 plus x raised to n. Formula for 1 plus x raised to n, application of this formula, say here 1 plus x raised to n, its easiest form is nc0 plus nc1x plus nc2x square up to last term is ncn x raised to n. So 1 is here, 1 plus is plus, now x is 100. So replacing x by 100 and n is 4. So by this formula 4c0, say here this is 4c0 plus 4c1 into 100, x is 100 plus 4c2 into x square plus 4c3 into x cube plus 4c4 x raised to 4. This is last term. NCN x raised to n is last term. So NC0, NC1x plus NC2x square plus NC3x cube, NCN x raised to n. So it is equal to 4C0 is 1, NC0 is always 1 plus 4C1 is 4 into 100 plus 4C2 is 4 into 3 upon 2 into 1. 12 by 2, that is 6 into 1, 2, 3, 4, 10,000 plus 4C3 is 4C1. 4C1 is 4, 1 and 6 zeros plus 4C4 is 1, 100 raised to 4, so 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is equal to 1 plus 400 plus 6, 1, 2, 3, 4 zeros, 4, 1, 2, 3, 4, 5, 6 zeros, 1, 1, 2, 3, 4, 5, 6, 7, 8 zeros. So now you can add these numbers. So adding these numbers, the value is, say here 1, then 1, 2, 3, 4, 5, 6, 1, keep here 10, then here 1, 2, 3, 4, 5, 6, put 4, then putting 4, 1, 2, 3, 4, put 0, then put 6, 1, 2, 3, 4, 0, then put 400, 0, 1. This is required addition. If suppose you are asked to find 99 raised to 4, if you require 99 raised to 4, then procedure is any power, 4 power, or if you are given here 5 power, any power given. Suppose I take here similar 4. Then what is the procedure? 99, it can be taken as 100 minus 1 is 99. Now see, whenever you get any one number from A and B, if any one number has value 1, say here you have obtained 1, here you had 1, we use 1 plus x raised to n, here we can use 1 minus x raised to n, but to apply 1 minus x raised to n, this should be at first place. So here power is E1, because E1 power, if you change order, then value remains unchanged, because x minus y raised to 4 is equal to y minus x raised to 4. So then you can apply this formula, 1 minus x raised to n, 1 minus x raised to n, 1 minus x raised to n is, we have nc0, alternate sign, minus nc1x plus nc2x square minus nc3x cube plus dash 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 ncn, then here minus x raised to n. So it can be done by this way. We keep alternate sign, plus minus, plus minus, plus minus. Automatically you will get sign of last term. If this power is odd, if n is odd, last term ends with negative sign. If this is even, then last term ends with positive sign. So minus x raised to n, there is a part in this last term, and even then it will be plus sign, and odd last term will be negative. So depends on n. Now suppose if here power is 5, suppose power is 5, if odd power, then you cannot keep this as it is. If there is odd power, and if you change order in the bracket, a minus b raised to n, and if you do b minus a raised to n, then minus comes out. Minus will be main sign. You have to put minus outside. And then you have to forward this minus sign till last term. And here you apply formula. You have to apply formula. Which formula? This formula. So this can be completed by this way. Now see, 96 whole cube. 96 whole cube, here this number is nearest to 100. So this can be taken as 100 minus 4 whole cube, that is 96. You should not take 1 plus 95. If you take 1 plus 95, then 95 square, 95 cube, 95 raised to 4, calculation of such numbers becomes difficult. But 100 square, 100 cube, it can be calculated very easily. So use in such type of questions, take base 100 if given number is nearest to 100, or take 1000 if given number is nearest to 1000. So now this is application of a minus b raised to n. A minus b raised to n. NC0 a raised to n minus NC1 a raised to n minus 1 into b plus NC2 a raised to n minus 2 into b square minus, then plus, then minus. Automatically it ends at proper sign. Continue alternate sign. So here NC0 a raised to n, a raised to n, then minus NC1. Now this will be decreased and b will be started, 4 raised to 1, NC1 a raised to n minus 1, b raised to 1, then plus 3C2 100 raised to 1 4 square, then minus 3C3 100 raised to 0, that is 100, 4 raised to 3. So see, it will be ended at a proper sign. If this is odd, you will have here automatically minus sign. If this is even, you will have plus sign. So you have to continue this by alternate sign, plus minus, plus minus, plus minus. Automatically it ends with a proper sign. So it is equal to 3C0 is 1 into 1, 2, 3, 4, 5, 6 minus 3C1 is 3 into 1, 2, 3, 4, 100 square 10,000 into 4 plus 3C2 is 3 into 2 upon 2 into 1, 6 by 2, that is 3. into 100 into 16 minus 3C1 3 is 1 64. So this is 10 lakhs 1 2 3 4 5 10 lakhs. Then next this is positive value plus 4800. These are positive numbers minus negative numbers. 4 into 3 12 1 2 3 4 plus 64. These are negative numbers. So it is equal to 1248600 minus 120064. Then taking subtraction 12480 120064. You can also do by calculator if calculator is allowed. Here 10 minus 4 is 6, 9 minus 6 is 3, here 7, 4, here 8, here 9 minus 1 is 8, here 0. 6 4 10 0 1 6 3 9 10 0 7 plus 1 8 4 8 plus 2 and 0 1 8 1 1 10 0 1. Okay, 884736. 884736. This is required value. Using a binomial theorem, indicate which number is larger, 1.1 raised to 10,000 or 1,000. So here we calculate 1.1 raised to 10,000. Say here 1.1 raised to 10,000 this can be expressed as 1 plus 0.1 raised to 10,000. Now applying formula 1 plus x raised to n. 1 plus x raised to n. So nc0 plus nc1 into x. nc0 nc1 into x plus nc2 into x square plus nc3 into x cube. This can be continued up to ncn ncn x raised to n. So 1 plus x raised to n is nc0 plus nc1x plus nc2x square plus up to ncn x raised to n. So this is equal to, now nc0 is 1 plus 10,000 c1 is 10,000 into 0.1 plus here 10,000 c2 into 0.1 square. These numbers we keep as it is. Leave these other numbers as it is. In calculation we require only these numbers. So this is 1 plus, this is 1,000 plus 10,000 c2 into 0.1 square plus and so on. Last term is 10,000 c 10,000 0.1 raised to 10,000. Last term is 10,000 c 10,000 0.1 raised to 10,000. It is last term. Now look, this is 1000. 1000 plus 1 I am putting in second place, plus now I keep these remaining numbers, 10,000 C2 0.1 square plus all the numbers. This value is 1. You can put here 1 also. So no need to write this lengthy expression. This is 0.1 raised to 10,000. 0.1 raised to 10,000. So this is 0.1 raised to 10,000. Now look, this is completely positive. It is positive value. So 1.1 raised to 10,000 is 1000 plus something. So this is more than 10,000, 1000. This value is more than 1000 because this part is positive. So therefore 1.1 raised to 10,000 is greater than 1000. This is larger. Find a plus b whole raised to 4 minus a minus b whole raised to 4. And hence evaluate root 3 plus root 2 raised to 4 minus root 3 minus root 2 raised to 4. So here, first of all, expression for a plus b raised to 4. Using a binomial theorem, this is 4c0 a raised to 4 plus 4c1 power of a is decreased and power of b is starting, plus 4c2 a square into b square plus 4c3 a raised to 1 b cube. A power of a is decreasing and b is increasing, and at last power of a will be 0 and b raised to n. So it is a plus b raised to 4. Now I keep expression for a minus b raised to n. Below this first line we arrange second line. Here only the difference is alternate sign. So 4c0 a raised to 4 minus 4c1 a cube into b plus 4c2 a square b square minus 4c3 a raised to 1 b cube plus 4c4 b raised to 4. Alternate sign. Now we want subtraction. So taking subtraction, we are taking subtraction. A plus b raised to 4 minus a minus b raised to 4 equal to, if you take your subtraction, then we keep here minus sign. This sign will be changed, minus plus minus plus minus. Subtracting second equation from first equation, you can see that now this will be cancelled, opposite numbers, this will be cancelled, this will be cancelled. So what is left? A plus b raised to 4 minus a minus b raised to 4 is, this becomes double times, this becomes double times. So double times 4c1 a cube into b raised to 1 plus 4c3 a raised to 1 into b cube. So these are left, both remains double time. So this is value of a plus b raised to 4 minus a minus b raised to 4. Now using this is the second part of question. We want to evaluate this expression. So say, look here, if we replace in this expression, we are putting a equal to root 3 and b equal to root 2, then we will get value of this required expression. So putting a equal to root 3, b equal to root 2, a equal to root 3, b equal to root 2, everywhere we put a equal to root 3, b equal to root 2, a equal to root 3, b equal to root 2. A is root 3, b is root 2. So this is equal to 2 into 4c1 is 4, 4 into root 3 cube is 3 root 3 into root 2 plus 4c3 is 4c1, that is 4 into root 3 into this is 2 root 2. So it is 2 into, it is 4 into 3 12, 12 root 6 plus 4 into 2 8 root 6. So this is 2 into 20 root 6. So final value is 40 root 6. So that is required value. Show that 9 raised to n plus 1 minus 8n minus 9 is divisible by 64 whenever n is positive integer. Say here 9 raised to n plus 1 minus 8n minus 9. We are going to show this result using binomial theorem. So here we can get hint from this expression to get binomial expression, pattern of binomial theorem. This is 8. So this 9 can be converted as, say 8 we are getting from this number 8. So this can be expressed as 1 plus 8 raised to n plus 1 minus 8n minus 9. Now see, application of 1 plus x raised to n. This is in place of n. Now we are applying this formula. nc0 plus nc1x plus nc2x square plus up to ncnx raised to n. So in place of x we keep here 8. And what is the power? N will be replaced by n plus 1. So here if we keep n plus 1, so everywhere we will replace here n plus 1, n plus 1, n plus 1. So applying this formula, n plus 1 c0 plus n plus 1 c1 into x, x is 8 plus n plus 1 c2 into x square plus n plus 1 c3 into x cube dash 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 n plus 1 c n plus 1 into 8 raised to n plus 1. N plus 1 c n plus 1, 8 raised to n plus 1. So application of this result. Now n plus 1 c0 is 1. If here this lower number is 0, value is always 1. Then nc1 is n. So n plus 1 c1 is n plus 1 into 8. Then say here we missed these two numbers, minus 8n minus 9, minus 8n minus 9. So this was expansion of 1 plus 8 raised to n plus 1, and at last there are these two numbers, we forward as it is. So 1 plus n plus 1 into 8 plus n plus 1c2 into 8 square. Now look, from this part I am taking 8 square common. 8 square common. So what is left here? N plus 1c2 plus n plus 1c3 into 8, because 8 square is taken common, plus this is 1 into 8 raised to 8 square is taken common, so subtract 2, so n minus 1, and these numbers as they are. So this is 64. So see, 1 plus 8n plus 8 plus 64, and this number I am saying m, this is m, minus 8n minus 9, where m is n plus 1c2 plus n plus 1c3 into 8 plus 8 raised to n minus 1. This number, it is a natural integer, it has a natural value, so this is belonging to n, it's a natural number. It can be any natural, because everywhere plus sign, and every such expression nc0, nc1, nc2, ncr has always natural value. So this has natural value. So you can see that this 8 and 18 is cancelled. 1 plus 8, 9 is cancelled with 9. So this is 64m. So this number is divisible by 64. Therefore 9 raised to n plus 1 minus 8n minus 9 is divisible by 64. It is proved. To prove this is equal to 4 raised to n, so beginning from left hand side, sigma r equal to 0 to n 3 raised to r ncr. So putting r equal to 0, first term is 3 raised to 0 nc0. Put r equal to 1, 3 raised to 1 nc1. Put r equal to 2, so 3 raised to 2 nc2. So continuing this, last value of r is n, so 3 raised to n ncn. Now see, rearranging this product, it is nc0 into 3 raised to 0. 3 raised to 0 is 1, so no need to keep anything. 1 into nc0 is 3 raised to 0 plus nc1 into 3 plus nc2 into 3 square plus up to ncn into 3 raised to n. So this is a pattern of expansion for 1 plus 3 raised to n. It is expansion of 1 plus 3 raised to n, so it is 4 raised to n. Now say in this topic there is a result that we know that 1 plus x raised to n is nc0 plus nc1 into x plus nc2 into x square plus up to ncn into x raised to n. Now what I do, I keep x equal to 1. I am putting x equal to 1. So we are getting, first of all I am writing left hand side, right hand side. Putting x equal to 1 everywhere, right hand side will be nc0 plus nc1 into 1, that is nc1, plus nc2 into 1 square is nc2, up to ncn into 1 raised to n is 1. It is equal to, now put here 1. So 1 plus 1 is 2, 2 raised to n. So this is said to be sum of all the binomial coefficients. Sum of all coefficients which appear in binomial theorem. That is sum of all binomial coefficients is 2 raised to n. As for example, suppose somewhere if you are asked that what is 50C0 plus 50C1 plus 50C2 up to 50C50. So by this result, NC0 plus NC1 plus NC2 plus up to NCn is 2 raised to n. This is its application. Then, now in this expression, on the left hand side, these are n plus 1 numbers. In these n plus 1 numbers, I am putting here nc0 plus nc2 plus nc4, means those numbers in which r is even, and those numbers in which r is odd, nc1, nc3, nc5. So these are numbers in which r is odd, these numbers r is even. These are coefficients of terms having even power. These are coefficients of the terms having odd power. So this sum is equal to this sum. Both sums are equal, and it will be half of this number, 50-50. So 2 raised to n is divided by 2. So 2 raised to n minus 1. So this is equal to 2 raised to n minus 1, as well as this is equal to also 2 raised to n minus 1. Both have value equal to 2 raised to n minus 1.